Hi, everybody. This is a video lesson for our light waves lesson 2.4. Let's dive in. So, first things first, we're going to go to classwork. Under the light waves unit should be this top one right up here. Of course, you've already found this if you're watching the video. So there are 4 things in here. There's the video, but also our key concepts, our login to Amplify, and a modeling tool. So just want to say right away, this is an assignment. You're going to need to complete the modeling tool and turn it in because it's going in the gradebook, and we don't like zeros now, do we? So, first thing I want to do for this lesson, though, is start with our key concepts. So again, we're studying how light interacts with different materials. Our chapter 1 question is, how does light from the sun cause skin cancer? And we're starting to see that different wavelengths can damage DNA. And today we're actually going to be learning about melanin, which is our skin pigment that protects us from ultraviolet radiation and other forms of radiation from the sun. So our chapter 2 question is, how can the same amount of sunlight cause different rates of skin cancer? Because remember, we compared Australia and Brazil. And Australia and Brazil get the same amount of sun, but the skin cancer rates are incredibly different. Before, let's see, our key concept from last lesson was a light source can emit more than one type of light, like the sun, or even a white light bulb. Different types of light have different wavelengths. And remember, it's the wavelengths that determine the kind of light that we have. We discovered that in our sim. And this is our new key concept for today, and it is a material absorbs energy from some types of light and not others. So now that we've kind of gone over our key concepts, let's dive into this lesson. There are 4 parts in Amplify. And I just want to remind everybody, you should be watching this video all the way through and following along, pausing the video throughout as you complete these activities. And I'm doing my best to try to make these videos short as possible, but also helpful for you guys. So the first thing we're going to do is we're going to read this little mini paragraph. Light that reaches the Earth's surface. Earth's atmosphere can absorb some wavelengths of light emitted from the sun. The diagram below shows which types of light are absorbed by the atmosphere, the air above our heads, and which types of light travel through the atmosphere and reach the Earth's surface. Use a diagram below to help you think about which types of light could be causing the damage that can lead to skin cancer. So here's the diagram they were referencing, and what they want us to know, they want us to start thinking about, okay, so not all of the light from the sun gets to us. Luckily, the X-rays and gamma rays are absorbed by our upper atmosphere, and even some of our other frequencies of light to some degree. But for the most part, ultraviolet light, visible light, infrared light, microwaves, and radio waves all make it down to the Earth's surface. So what you want to do now is do some speculation. You might not know the answer for sure, but make a prediction. Which types of light reach the Earth's surface? Well, that question's pretty easy. We can get that from the diagram. So go ahead and pause the video and answer those questions, or that question right there. So friends, hopefully you paused the video and you were able to complete that part by yourself, because all you had to do was look up here and determine that the X-rays and the gamma rays are the only ones that don't reach the Earth's surface. All these other kind do. So now, from the types of light that reach the Earth's surface, which do you think could be the cause of skin cancer? Explain your reasoning. So go ahead and pause the video and answer this question. I'll share my answer when you come back on the flip side. Hey friends, in this distance learning environment, I'm not really doing a lot of discovery where I kind of point you in the right direction and then, hopefully you're able to figure it out on your own, because usually that level of learning is way deeper. I'm not doing that much of that. Here's the answer. It's ultraviolet. All right, so let's move on to the next one. Don't forget to push that little hand in button. So now we're going to be doing a couple of things. We're going to be doing the sim, but we're going to be recording our information onto our modeling tool. Now, if you just follow me along, I'll take you through it step by step, okay? So we're looking back at this diagram here. And our goal is to show what happens to genetic material when it's exposed to different kinds of light from the sun. So what we're going to do is we're going to open up our light wave simulation. We're going to follow these steps, and we're going to use the laser to test these different wavelengths of light. So ultraviolet, visible, infrared, microwave, and radio. So hold on. And the material we are going to be testing is genetic material in that sim. Now, we should probably just pause right now, though, and open up our modeling tool. So go ahead and do that now. Go back to Google Classroom, open up this modeling tool. Because before we go any further, I want to share with you how to record this data. So there we go. I thought I'd make this just a little bit bigger for you. So notice this is Model A. If I click the button, I'm now on Model B. So this is a separate slide. Now, you are going to be testing all of these wavelengths of light. You're going to be testing ultraviolet, visible, infrared, microwave, and radio. Okay. Now, as you test these, our sun is going to be our primary source. And as we test those different wavelengths of laser light, we're either going to enter them in the no change category or on this other page, Model A. And then we're also, if we do see a change, so if we say ultraviolet and we see a change, we're going to take that change and we're going to drag it up to here. Also, we are going to illuminate our energy source. So follow along with me, friends. First thing we're going to do is open up our sim and follow the steps. So we need to fry some genetic material, right, with a laser that is in these wavelengths. So let's open it up. Okay, so we want our laser turned on. And what was the first wavelength? Was that ultraviolet? UV, absolutely. So red is, oh no, there's violet. There we go. So now we have now we want it to be ultraviolet. So make sure it says ultraviolet over here. And we want to get our genetic material, that's our little double helix here. I'm actually going to show the energy too, because I like doing that. That's in the upper right corner. And let's blast it. Okay, so we can check that light beam. So we already know that's UV. Let's inspect to see what's happening though. So it is damaging. So we tested our genetic material with the laser and we did UV light. That was our first one. Now in the sim, it's saying we have UV light and the effect is damage. So now we need to record that data. So we're going to go over to our modeling tool and we're on this one. And so page 1, that's model A, that's the one that shows changes. If we didn't see a change, we would record ultraviolet here. But instead, I'm going to make this a little bit bigger. There we go. I think the first thing before we go too deep in here is we should probably take our little sun, drag him over. There you go, little fella. We'll take this guy. We want to turn that line color yellow because we want to show the energy path. Okay, so now what we're going to do is we just did ultraviolet. So we're going to take ultraviolet. We're going to drag it over. And the change that we saw was indeed damage. Okay, so we've tested our first frequency of light. Our next frequency is visible, any color we want. Sweet, I'm going to pick back to green, I think. Okay, so what's happening here? Some of it's going through. Oh, look at that. There's absolutely no change. I wonder if it's different with a different color. No, no change whatsoever. So now we can go back to our modeling tool, and we want to go not to this side because this is model A, and this is the model that shows the change. This is our no change side over here. So let's go ahead and grab our sun, get that all figured out. And let's go ahead and do our energy line to show that we know, whoops, that energy is transferred in a straight line in the laser. Where's my color at? Yay, there's my line color, and we'll turn that one to yellow. Okay, so we've got our sun. We had just tested visible light, and bada bing, we are done with that one. Let's go see what's the next one, infrared. So now we need to go to the other side of the spectrum. We're just going to take our little slider. We're at red. Now we're going to go infrared. And let's inspect it. Increased kinetic energy. Look at that. So we can go back to our modeling tool. And we can go to infrared. We'll drag that one over. And what was the change again? Increased kinetic energy. So that could be movement or heat. Okay, now let's go back and see what our other one is we need to test. We need to test microwaves. Let's do that real quick. Let's see. Nope, I went to radio. There's microwaves. Okay, so we've got our microwave laser beam going here. And there is no change with those big, long microwave wavelengths, no change. So we will go ahead and put microwaves on slide 2, because that was a no change. Boom. I think we're almost done. What do we have left? Microwave, oh, and then radio. That should be easy. So we'll drag our slider all the way across into that radio wavelength. And let's inspect, see what's happening. No change. So let's go over here. Let's grab our radio wave. Sweet. Oh, no. There it is. Ta-da. So we've got page 1 done. It should look like this. And then we've got page 2 done. So we've recorded all of our findings from the sim. So now, let me move this guy. So as we're going along here, we are going to summarize our results. So after you've tested the 5 types of light from the sun that reach the Earth's surface, answer these questions. Which types of light are absorbed by genetic material? I'll let you go ahead and pause, and you can go back to your modeling tool for those answers. The next question I want you to answer is question 2 using your modeling tool, question 3, and then also question 4. Go ahead and pause the video and do that now. All right, friends, hopefully you were able to answer those questions. And drum roll, which types of lights are absorbed by the genetic material? Well, that was the ultraviolet and the infrared. We can see that right here on our modeling tool. And moving on to question 2, which types of light cause damage? Well, the only one that caused the damage was ultraviolet. The infrared just caused an increase in kinetic energy. Which types of light are not absorbed by genetic material? So that would be the visible light, microwave, and radio. So by not being absorbed, there's no change from these wavelengths of light. So based on your investigation, can ultraviolet light cause damage that leads to skin cancer? Yes. Can visible light cause damage that leads to skin cancer? No. Can infrared? No. Can microwaves? No. Can radio waves? No. So now if we go back to our initial warm-up question, we have just discovered the absolute truth on our own. We don't even have to trust Mr. Roberts. Ultraviolet light can cause skin cancer. So let's go to part 3. So part 3, we're going to investigate these 2 claims right here. What we're really trying to do is answer this question: can a light bulb cause skin cancer? Well, I'm going to answer that with it depends on the light bulb, right? You can say tanning beds are light bulbs, but we do have some images here to help us. So claim 1 is that light from the sun and light from a light bulb can cause skin cancer. Claim 2 is light from the sun can cause skin cancer, but light from a light bulb cannot. And I'm assuming if we look down, they'll tell us what kind of light bulb and what kind of light is being emitted. So please don't get in your head that this is a tanning bed light bulb, okay? Because they're showing you right here that it's this kind of light bulb. It's emitting infrared and visible light, so more like a typical light bulb that you would find in the house. Here, of course, is the sun with all of its wonderful wavelengths of light that it emits. So the image below is taken from the sim. And we want to dive into these claims. So one of them is light from the sun and light from the light bulb can cause skin cancer. Claim 2 is that only the light from the sun can cause skin cancer. So what I'd like you to do is just take a moment and pause the video and get your thinking down, okay? Can this light bulb, as it's shown, cause skin cancer? Or is it just the sun? Think about it for a minute. Pause the video. Now, hopefully, we've discovered along in this lesson that really ultraviolet radiation is the key thing for skin cancer. The light bulb here is not, it's violet, but no ultraviolet. So, which claim do you agree with? I think it was claim 2, right? Is that the one we want? Light from the sun can cause skin cancer, but not light from the bulb. Yes, I think we can do that. Which claim does your partner agree with? I am your partner. I agree with you. I think claim 2 for sure. Now, what evidence supports your claim? Go ahead and answer this question. Pause the video. Come back to me and I'll share my answer with you. Same one with this question here. All right, friends. Hopefully your answers look something like mine. Here's what I put for the evidence that supports the claim. According to the data gathered from the sim, and remember, we always want to point back to the evidence, pointing back to the data. According to the data gathered from the sim, only UV light can cause skin cancer. Some new. That's the sun, Roberts. The sun emits UV light while the bulb does not. So for this one, looks like I got a few grammatical mistakes in there, but that's okay. Ultraviolet UV light is absorbed by the genetic material in skin cells, so it can cause damage. This damage can lead to skin cancer. Visible light is not absorbed by genetic material in skin cells, so cannot cause damage. So remember, it's all about the absorption. If the material can absorb the energy from the light, then yeah, it is going to cause some sort of change. Push that hand in button and let's go to the homework section. The homework section, we are going to finish off with a short little read. I just want to point out you can have it read to you if you need that. But we're going to take a deep dive into this very important substance to the human body called melanin. So we're going to read that article, and these 2 questions are entirely for you. I can't give you these answers because it's what did you find interesting about the article and what questions do you have about melanin? Read the article, answer those, push the hand in button, and thanks for being here with me. I appreciate all of you guys. Don't forget to like, share, comment, subscribe, and always be nice.